Okay, you're live.
Welcome, everybody. Thank you for joining us for our hands-on workshop today on how to build Web3 apps with Hyperledger FireFly SuperNodes. Really excited to have everyone today. We had a great webinar last week talking about FireFly and the 1.0 launch, and there was a brief demo at the end of it. But I think there was a lot of desire to go deeper on some things and to really get more hands-on. So today's going to be hands-on, and I'm really looking forward to it. Before we get in, just here's the agenda of the things that we're going to be going over today. I'm going to cover a couple of housekeeping items. I have a few slides to kind of set the context for the workshop, as well as introducing FireFly. The bulk of this time will be the hands-on workshop. Will actually be in a terminal and in a web browser using FireFly and doing blockchain stuff. So it's going to be really exciting. We're going to leave about 20 minutes at the end for some roadmap discussion and Q&A. But again, the bulk of it is going to be the workshop. The whole session will be an hour and a half. So that's the agenda. Onto some housekeeping items. Please note that this workshop is being recorded. This workshop must abide by the Hyperledger Code of Conduct and the antitrust policy. If you're not familiar with those, you can find them both on the Hyperledger Foundation wiki, or I guess you can't really click the link there, but my slides are linked to them. A couple other housekeeping notes. There are a lot of us in this Zoom, which is awesome. I'm happy to see such a great turnout. Please keep your mic muted if you're not speaking. Right now, I'm the only one that's speaking. So if you're not me, please go ahead and go on mute just to cut down on background noise. Please prefer chat as the first resort for asking and getting questions answered. And again, we would prefer you using the Discord chat. As David was mentioning earlier, the Discord chat in the Hyperledger Discord server under the FireFly section, there's a dedicated FireFly workshop channel that we just created this morning. So go in there. Some of the other maintainers are monitoring that, and I will be happy to answer questions as we go along. If you'd like to speak during the workshop, that's okay. I would love to keep this interactive, but just please go ahead and raise your hand and wait to be called on. Again, there's a lot of us in here, and this will just kind of help us keep it organized and keep on time. I'm happy to take some questions as we go, but there's a lot to cover, and I'd really like to keep us on track and on time. So that's it for housekeeping items. Thanks for bearing with me while we go through that. Let's talk about what we're going to do in the workshop today. So we're going to use some pretty cool tools here today. You may be familiar with Hardhat already. Hardhat is a pretty common tool for doing Ethereum development, testing, contract deployment, and that sort of stuff. So we're going to use Hardhat, and we're going to compile a custom smart contract. We're going to deploy it to a blockchain node running on our machines, and we're going to use that contract with FireFly. And what we're going to be doing today is I'll have a slide on the end result, the end goal of the workshop in just a minute. But the other awesome tool that we're going to be using is Hyperledger FireFly. That's probably what most people are here to learn about today. Hyperledger FireFly, if you are not familiar with it or didn't get a chance to watch our webinar last week, we described FireFly as the first open source SuperNode, which is a complete stack for developers to build and scale blockchain Web3 applications. So what is the value of FireFly? Where does it fit in the blockchain ecosystem? Well, it's not a blockchain itself. It's not a DLT. It sits a layer above that. But FireFly, the value to a developer, I'm assuming that most of us are developers in this room. And so kind of looking at things through that lens. The value to the developer is that it takes care of this whole stack of things that a developer needs to build. You can see on the left, we have this diagram of okay, at the bottom, we have our blockchain and our smart contract. And that's kind of oftentimes when we're building a Web3 app, that's what we think of first. We go to, okay, what's the logic that goes on chain? What's the smart contract look like? And then all the way at the top, we have, our business application, our web UI, our user portal, or maybe, some sort of business back office system that needs to be integrated there. But how do you connect all of the things in the middle of that. There's once you start getting into building an enterprise Web3 application, you realize that there's a lot of plumbing and a lot of electrical work and all these things that are not very fun things to develop that you still need in order to actually build out an entire enterprise grade Web3 application. So that's the gap that FireFly fills. It's a platform. It's a common foundation to build enterprise Web3 apps. So what types of things does it have in it? It's got a lot. If we kind of break it down into three main groups, though, you've got apps, you've got flows, and you've got digital assets. And we'll actually walk through a bunch of these use cases in a little bit, kind of breaking them down into these three groups. So at the center, you've got the FireFly core. The FireFly core is an orchestration engine, and it's coordinating things that are happening on the blockchain, things that are happening off-chain. It provides a really easy to use REST API for developers to access all these functionalities. It provides an event delivery mechanism over WebSockets. Some of the other really cool things about it is that it's a microservice architecture, and it's very pluggable. So there are specific implementations that we'll talk about, the things that we're going to be running on our machine later. But if you want to use a different database, for instance, or if you want to use an entirely different blockchain, those are plugins into FireFly. And so FireFly is very modular. It can adapt to meet specific needs for specific business cases. And it's a really cool architecture. So I'm not going to spend a ton of time on what FireFly is and all the value that it brings. There was a great webinar on that last week. I hope that as we use it, you'll start to see the value and some of the power behind it and the really cool features. But I just wanted to paint a little bit of a picture before we jump in here. Okay, so what are we going to build today? Today, my goal is that you walk away from this workshop having all the pieces that you need and the understanding to go build a Web3 app with its own token economy powered by FireFly. So how are we going to do that? We're going to use Hard Hat. We're going to compile and deploy a custom ERC20 contract. We're going to use the FireFly sandbox to walk through using FireFly's APIs in a very approachable, user-friendly manner, which will provide us sample code snippets that we can look at to see, okay, how would we go build this feature into our backend, into our application that we're going to build in the future. So at the end of today, you won't have a full end-to-end working application, but you should have all the knowledge and all the pieces that you need to go build that. And would love to just see the creativity that people and come up with and the ideas that this will spark as people start to see all the different things that they can do with FireFly and an understanding of how all the pieces fit together. So the things that we're going to be doing in the sandbox, we're going to create an API. We're going to look at the Swagger UI that's generated for our smart contract. We're going to mint and transfer tokens from the Swagger UI. We're going to create a token pool to let FireFly index all of the ERC related transactions. We're going to send broadcasts and private messages and kind of look at all of the three main groups of features in FireFly. And throughout all that, we're going to be using the FireFly Explorer to inspect and kind of see what's going on inside FireFly as we're doing these things. The tools that we're going to use, again, so we're going to be using Hard Hat. The other tool that we're going to be running on our machines is the FireFly CLI. I'll walk you through how to set that up in just a minute. FireFly CLI is a tool that will set up a local FireFly development environment on your machine. It uses Docker Compose to do this. That's why Docker is one of the prereqs. And it gives you all the components of what we describe as a SuperNode right on your laptop. So what goes into a SuperNode? So what we're going to be running when we run the FireFly CLI and it starts up a development stack is, so we're going to, you'll hear me talk about different members of the FireFly network. So you can think of different members as perhaps different organizations or different companies. Remember, this is the context here is building enterprise Web3 apps. So you may have different businesses that need to transfer data, transfer tokens, perform business transactions backed by blockchain. So that's what each of the members are going to be in our FireFly network that we're going to stand up, or our FireFly stack. Each of those members has their own SuperNode. And so inside the SuperNode, you have a FireFly core over here. Each FireFly core is connected to a database, data exchange, blockchain connector, tokens connector, so on and so forth. There is To keep things simple and as lightweight as possible, there's one blockchain node that will run on your machine, and both SuperNodes will end up actually just sharing that same blockchain node. So as we're going through, we're going to be using FireFly Core's API. We're going to be using the web UI, the FireFly Explorer, to look at what's going on inside there. That web UI is actually hosted by the FireFly Core. We're also going to be looking at the FireFly Sandbox. You can think of Sandbox as an application that sits outside the SuperNode. It's an example of an end user application that is written to use FireFly's API. So it's not part of the SuperNode, but we ship it with the FireFly CLI because it's an awesome tool to learn about Firefly and try it out all in a web browser. It will also provide code snippets of how to use how to build these functions in the backend. Okay, so before we jump in, I'm just going to check on chat here. It looks like there's a few questions that have been going on here. Any big questions that any of the other Firefly folks that are online think I should address before we hop into actually getting hands-on? Okay. I'm going to share my full screen now. Give me just a second to do that. All right, here we go. So here's our workshop guide. This is the GitHub gist that I linked to earlier. Hopefully the font size is readable for everyone. Kevin, does it look like it's coming through okay to you?
Yeah.
Okay, great. If I need to adjust font size or anything, please just let me know. I'm happy to zoom in on stuff. Hopefully the screen size should be good though. Okay, so hopefully you've had a chance to go through the before the workshop section and make sure you have Docker. The FireFly CLI will also use OpenSSL. We'll also need Node.js installed. Hard Hat uses Node.js, and so that's why we need that as well. So increase font size. Got it. Good.
Yeah.
Okay. All right. So what we're going to do first is I want to get the environment created and get a blockchain node running on my machine. So we're going to use the FireFly CLI to do that. I'm basically going to walk you through the getting started guide. So if we pop over to the FireFly docs, this is the getting started experience for folks who are coming new to the project. I walk you through installing the CLI, starting an environment, and using the sandbox. I'm going to be walking you through that today. So we're going to start with installing the FireFly CLI, which is the first step there. Okay, so if you happen to be a Go developer and you have Go set up on your machine, you can just go install the FireFly CLI. If not, that's okay. If you don't want to worry about setting up a Go dev environment, that's not a requirement. In that case, we can go to the releases page. So we'll see, go to download the package for your OS, go to the latest release page on GitHub, and we will just download the appropriate binary for our machine. So I'm running on an M1 Mac here, so I'm going to download the Darwin x86, sorry, ARM64. They both have a 64 in them, so I oftentimes get them confused at first glance. Okay, I'm going to download that, and make sure you download the one that's appropriate to your system. If you are running on Windows, you should be able to use the Linux binaries in Windows Subsystem for Linux 2. And if you have Docker set up to use WSL2 as well, that configuration should work for you. Okay, there's a handy command here. Basically, we just need to unzip this thing and put it somewhere on our machine that we can call it. I've got a command here that I can copy and paste to put it in my bin directory. So I'm just going to do that here. I'll make my font a little bigger in my terminal. Ask me for my password because that's a directory, and I can type it correctly. Okay, there we go. So now that we've got, I have the FireFly CLI binary installed in my bin directory, so I should be able to run FF version. And you know what? I have a version compiled from source. Hang on, let me get rid of that. Sorry about that. Okay, so if I run FF version, now my Mac is going to say, hey, you didn't pay Apple a whole bunch of money to sign this, so I'm not going to run it. That's okay. We can deal with this. You just hit OK. It's going to kill it. That's fine. You'll go to System Preferences, go up to Security and Privacy, and then so it'll say FF was blocked because it's not from an identified developer. We'll allow that. That's fine. The next time we run FF version, it'll say, hey, are you really sure you want to run this? Yes. Okay. And then there we go. Okay, so I'm running 0.0.48. So that's the latest release that's out there. And hopefully you've been able to get that and run that on your machine as well. Okay, let's go back to our guide and see where we're at next. So we got the FireFly CLI installed. Now we're going to create an environment. So this is kind of step 2 in the FireFly getting started guide is, set up a dev environment. I'm going to use a slightly different command than what's in the FireFly docs because I want to use ERC20 and the default is ERC 1155. And then I also want to customize the names of the organizations. So this command is going to initialize a new stack. It's going to call it workshop. It's going to create a network of 3 members. That way we can demo both public and private transactions. And I'm going to use the ERC20, ERC721 token connector. And then the prompt names command here is going to just let me type in my own names for all the organizations and nodes. Before we create it, I just want to highlight real quick all the different. So if you want to see all the different things that the FireFly CLI can do, you can run FF help. It will print out, here's all the commands that the FireFly CLI can do. If you want to know, hey, what are the different things I can customize in a FireFly stack when I create it, you can run FF init -- help. And here's the full list of options. So you can customize which blockchain it uses. If I add a -B space fabric, it will use a fabric blockchain. We're not going to demo that today. We're going to focus on ERC20 on an Ethereum node, but you can do that. You can have it use Postgres instead of the built-in SQLite database. You can enable Prometheus metrics. There's a bunch of different options that you can set here. Okay, so I'm going to just copy this command here. Oops. And I'm going to run this. And for clarity of the workshop and the demo, I'm going to name my organizations and nodes red, green, and blue. And I have 3 different themed Chrome browsers that should match those colors if I get the order right here. And so you can name them whatever you want. The name here is not important. If you don't use prompt names, then it will just go with default names of org0, org1, etc. So I'm going to call this one red, and then I'm going to name the node for this one red node, and I'm going to call this one green, and green node, blue, and blue node. This will just visually help give a little bit of an indicator of when we're looking at the 3 different browsers, which perspective we're looking at the network from. Okay, great. So we have initialized the stack. We're not running it yet, but let's go ahead and do that. Before we run it, just wanted to call out, if you are running on a machine like mine on a Mac that actually runs Docker containers inside of VM, we want to make sure we have enough RAM allocated to run this because it will start up quite a few Docker containers. If you need to double check that, you can go up here to the Docker desktop and click on dashboard. We can hit the little gear icon here and then click on resources. I recommend at least 1 GB of RAM per member. So I'm using 3 members here. I usually give my Docker VM like 7 or 8 gigs of RAM, and that tends to be great. So just wanted to point that out. If you don't have enough RAM, unfortunately, some of the unfortunately, some of the processes struggle a little bit with not having enough RAM. Okay, so now we're going to run FF start, and then we're going to tell it to start the workshop. All right, so we'll let this go for a little bit. It's going to pull some Docker containers. It's going to initialize our blockchain node and start everything up. I'm gonna pause and kind of catch my breath here a little bit. I I also got feedback that I maybe need to slow down a little bit because folks are trying to follow along. So I apologize if I'm going through this too quickly. There's a lot of exciting stuff I want to share, but just checking out chat here. Okay. Before we hop over to Hard Hat and start looking at the contract, anything that I can help clarify or any questions that we want to address before we move on to kind of the next phase here in the guide?
So I think the questions, Nicko, I can just see as we've been tracking in the chats. I think we've got people following along, which is fantastic. And as you're going, and people have been just really focused on making sure they've got what they need on their machine. I wonder if a couple of people maybe on the chats could just know if they've got there successfully. Just get a confirmation from a couple of people that they've got there to this point, and whether we need a couple of minutes to just allow people to catch up here.
Sure. Yeah. Has anyone been able to get to this point where they've been able to start a stack on their machine along with me here?
I'm starting my machine. It's initialization.
Awesome. Okay. It may take a little bit longer than what it did on my machine. I probably had a lot of the Docker images already. So, okay. Yeah. Somebody had something listening on. So there are quite a few ports that are exported. That's probably something I should have noted as well. There's quite a few ports that the Docker Compose file exports. And so it should, if there is a port collision, the FireFly CLI should tell you which port it tried to grab and found something else listening on already. Okay, so it sounds like some folks are tracking along or are very close to getting a stack started up. So that's great.
Sorry, Nicko.
Go ahead, Peter. Go ahead.
The team here is gonna, if you're on Mac and you've got a recent install of the Apple operating system, it may have enabled a system for sharing an AirPlay.
Yes. Okay. Yeah. Let me thank you for that reminder. That was a while ago. I forgot about that. Okay. So in the thanks, Apple, for this. In the latest version of Mac OS, there is a new feature that Apple added, and it happens to listen on port 5000. If you want to disable that, I'll walk you through that right now. It's an AirPlay receiver. And so I just go to System Preferences, I go to Sharing, and there is a thing at the bottom here called AirPlay Receiver. This will listen on the port that the FireFly core wants to allocate to itself. So if you just uncheck this and then try to run ffstart, that should solve that problem if you're running on a Mac and running into the port collision there. That was a good call out, Peter, and thank you. I had forgotten about that. Okay, let's go back to our guide here. All right, so we have ran start workshop. Now we're going to shift gears and look at our contracts that we're going to deploy. So what have we done so far? We've set up a FireFly development environment on our machine. We have a blockchain node running. We haven't done anything with it. We will go look at it in a little bit, but we're going to kind of shift gears now and then go look at Hard Hat, which is a different tool. This is a tool that Ethereum developers are probably familiar with. And so we're going to look at, how do we take an existing workflow that people are probably familiar with, or at least some of the concepts that they're familiar with, and use that with FireFly. So FireFly has this concept of a tokens connector, and a tokens connector is a bridge. Sorry, it's not a bridge. It's a component that sits in between the FireFly core and the blockchain node itself, and it is written in such a way that it knows about what type of contract that it's supposed to be working with. So in the FireFly Hyperledger GitHub repos, there are two different reference implementations of what a token connector might look like. If you are building your own smart contract, your own token implementation, and you want to run on FireFly, we highly recommend you should build a token connector that is knowledgeable about your specific contract. But there is a reference implementation provided for ERC20 and 721, which we're going to be looking at today. So we're going to clone that GitHub repo. I'll hop back over to my terminal. I'm going to go ahead and just open a new tab in my terminal here. And then I'm going to go to my code directory, and I have a workshop directory in there. There's nothing in here right now. So I'm just going to clone this repo here. You can clone it anywhere you want on your computer. And then if we look at the guide again, it says cd into that directory. And then inside there, there's a Solidity directory. So we just cloned the source for the whole token connector. We're not going to run the whole token connector because we're actually already running it in our Docker environment. But what we need is the Solidity files that are in there. So if we look at this directory, it has some files in it. If we look at the contracts directory, there are some Solidity files in there. So I'm just going to actually open up my IDE real quick and show you what is in there. That's probably a little too big. There we go. So we look at contracts. We see there's this is the contract that we're going to deploy. It's ERC20 with data. This extends the OpenZeppelin ERC20 contract. I haven't installed dependencies, which is why we're getting all the red underlines here. We'll solve that in just a minute. And so, yeah, so this extends OpenZeppelin and implements ERC20. And FireFly has this concept of being able to associate data with the transfer. So that's what ERC20 with data is all about. There's also a contract provider for 721. We don't have time to look at that as well today. Would love to do a separate talk on NFTs, but you should be able to take everything that we have talked about here today, and with some minor changes. Also, you could do the same with 721 if you wanted to, but we're going to focus on ERC20 today. Okay, so I'm going to hop back over to my terminal, and actually I'm going to go back to the guide, and it says now run npm install. So that's what we're going to do next. So again, I just cloned the repo, I cd into it, I'm in the Solidity directory, and I'm going to npm install. This will install Hardhat. It will install the OpenZeppelin contract dependencies and everything that we need to be able to compile our contract. So we'll give that a second. Okay, great. So we've got our dependencies installed. We'll pause to kind of make sure people are keeping up here. Any questions or comments that I can address while we're kind of letting people get the repo set up, get things installed?
Another sort of public announcement, if you haven't seen it on Discord, if you have a permissions error trying to git clone, make sure you're using the HTTPS link to clone the repo, not the SSH link.
Apologies for that. I would have thought SSH should have worked for everyone. So that would look like git clone, and instead of git at github.com, do https://github.com/Hyperledger FireFly. And I can just drop this in chat as well, so everyone has this here. Should be HTTPS, probably. Okay. hopefully everyone can clone that repo, run npm install, and get the dependencies installed. Again, we're working in the Solidity directory inside there. There's a question: is it possible to use Rust rather than Solidity on the dev side? As long as you can compile and deploy an Ethereum smart contract onto the chain, you're welcome to use whatever tooling chain or language you would like. The end goal here is to get a smart contract on chain. So that's Hard Hat and Solidity are the tools of choice here for today. But as long as you can get an Ethereum contract deployed to the blockchain node you're running locally, you're welcome to use whatever tooling you want. You can use Truffle or any other tools that are common Ethereum smart contract development tools. Okay, now we're going to run it. So, we're going to compile and deploy it. So if we look in, just so you can see what's going on here, inside the Solidity directory, there is a scripts directory, and there's a deploy script here. This is, we're going to run this script, and this will compile and deploy our smart contract, and it will print out the addresses that it has deployed the contracts to at the end. I see someone has raised their hand. Yeah, go ahead.
Hi. Does the FireFly SuperNode runs an Ethereum node that are going to deploy to, or Ethereum-like node?
Yes, it does. Yeah. So great question. And I can just show you real quick after we ran our stack, I could run Docker PS, and we can see all the things that we have running here. So sorry, some of my Zoom windows are in the way a little bit, but we've got, we have 3 FireFly cores. We have 3 token connectors, 3 blockchain connectors. And then right here, this is our Go Ethereum blockchain node that's running on our machine. And so internally, it's listening on 8545. Yeah.
So I'm going to talk directly to that node to deploy and work with my contract, or I'm going to use another interface of FireFly.
Yeah. So we're going to have, great question. And let me show you what's going to go on here behind the scenes. When we run this deploy script, it's going to use there's a hard hat config.ts, and this is an important detail. So great question. Thank you. I've already put in this repo a configuration to use the FireFly network that's running locally on your machine. And so here we've configured a network called FireFly, and we've told it, this is the URL of the blockchain node, and this is what Hard Hat will talk to when it goes to deploy this contract. So hopefully that clarifies there.
Yes, thank you.
Yep. Did I see someone else with their hand up that had a question? Okay, maybe not. Okay, so yeah, so great question about, how does the deployment work? So, we have a blockchain node running here. That's where we're going to deploy to. And this script is what's actually going to do it. So to run this, we can just go back to our guide and run npx hard hat, run scripts deploy.ts. And so we'll make sure we do that in the Solidity directory. We'll just run that command. This will compile our contract. We may see a couple of warnings. That's okay. I am going to go look at those later, though, and see if we can clean that up. So that compiled it and it deployed it. And so we can see here at the output, we can see our ERC20 contract was deployed to this Ethereum address. We can see our ERC721 contract was deployed to this Ethereum address. So this is great. We have a contract on chain, and now we can start to use this with FireFly. I'm gonna take another moment to pause here because we're about to shift gears now and go start looking at actually using FireFly with this contract. So I want to make sure that, if people are following along and trying to keep up, we get at least to this point where we have the contract on chain, because that's a kind of a big milestone in the workshop, is making sure we get our contract actually deployed. So I'll just kind of pause for a minute. Folks have a couple of questions. I can take a minute to answer those as we go here. Somebody asked for the link to the gist. Yep. Yeah, sorry, let me send that to everyone here just in case. Okay. Yes, Mustafa, you got your hand up. Go ahead.
So the connector, the coin connector, what does that? What's its rule here? Does it like connect Ethereum contract?
Yeah, I'm glad.
Yes.
Yeah, I'm glad you asked. We have not actually used the token connector yet, but that's going to be one of the really cool parts of the workshop here in just a few minutes.
Okay, thank you.
Yep. Okay, yes, we are recording this, and the recording will be made available afterward as well. All right, so I'm conscious of time here, and I want to make sure that we get to look at some of these really cool features of FireFly. So we're gonna jump into the FireFly sandbox now. So there is a guide in the docs on this is kind of step 3 of the getting started experience in FireFly, which is using the sandbox. There's a video walkthrough from the webinar last week. A little bit of a description of what the sandbox is. Again, it's an end user. It's written as an end user application, so it sits outside the SuperNode. It uses FireFly's API, and it's kind of broken up into these 3 columns here. I'm going to actually open it up. There is a link here right in the docs that should open up the UI for the first member. I'm going to try to keep things straight by using these color-themed Chrome browsers. Remember, when I set up my network, I named them red, green, and blue. And so I'm going to open up the sandbox for the first node here. So this is what the sandbox looks like. It is kind of broken up into 3 columns. And on the left here, we have a form that we can fill out that will prepare requests for us. In the middle, we have an example of some server code that will, you can think of this as like, if I'm building a back-end application that is designed to use FireFly, here's an example of some code that I can go take and put right in my application. This uses the FireFly SDK. This is Node.js TypeScript code here using our Node.js SDK. There is SDK support coming for more languages in the future, but right now we've got Node.js. And so that's what this FireFly variable is here. It represents an imported Node.js SDK. We're going to start on the contracts panel. So there's 3 different panels here: messaging, tokens, and contracts. We're going to start with our custom contract that we deployed. And so you can imagine a use case where I'm building an app that has an ERC20 token economy built into it. But it's a custom contract. It has extra features. It has things that are not in the standard ERC20 interface. And I want to use FireFly to interact with those features. So that's what we're going to show first. Just a couple of concepts here that I want to go over. So we have in FireFly a thing called a contract interface. So first of all, there's some helpful hints here on how to deploy a contract. We've already done that because we walked through that with Hardhat. I want to just take a brief moment and talk about contract interfaces and contract APIs, because these are some building blocks of really powerful features inside FireFly. So in the Ethereum world, we have Ethereum ABI format, which describes the inputs and the outputs and events and all the type information in a smart contract and all the functions that it has. And this is a great way to just inform a system about the shape of a smart contract. Now, FireFly is multi-chain, multi-protocol. And so it works with Ethereum, but it also works with Fabric, and it could also be extended to work with other types of blockchains. So we wanted a way to be able to describe a smart contract for any blockchain. So that's what the FireFly interface format is all about. It is a way to describe a smart contract in a blockchain agnostic format, yet still encapsulating blockchain specific important information like the type. For instance, for Ethereum, you'll see inside an FFI, it still embeds the specific EVM type that a variable will be treated as in the EVM. And so this also has the advantage of now we have a way to define an interface that can describe, for instance, a Fabric chain code. And it doesn't matter what language the particular chain code is implemented in. We have a way that we can talk about smart contracts in a way that's blockchain agnostic. So what we're going to do is we're going to tell FireFly about the shape of our our ERC20 contract that we've just deployed. So FireFly doesn't know anything about it right now. It's just on the blockchain, but FireFly doesn't know where it is or anything about it. Because we're using an Ethereum contract and we already have an ABI, FireFly also has a convenience function to convert that Ethereum ABI into an FFI or FireFly interface. And that saves me as a developer a bunch of time typing out a bunch of handcrafted JSON, which is probably going to be error prone. So what we're going to do is we're going to switch this toggle to ABI JSON, and we're going to just paste in the ABI here from our contract. So you can find that if I go back over to my IDE, I'll tell you where you can find it, and then it's also in the gist. So you don't have to go digging for it, but just for your knowledge, it's going to be under artifacts. It's going to be in build info, and it's going to be in this big, long, ugly JSON document. It's in here, I promise. There's a bunch of other stuff in here though. So to save time from sorting through that, I've actually already copied that out and I have put it in the guide here. Just for convenience, I've also included a copy here. So you can, select this whole thing. And again, this is just the Ethereum ABI for that contract that we have compiled. And we're going to copy this. I'm going to go back to my Red browser for my Red member here. And I'm just going to paste this whole thing into this box here. Okay. I need to give it a name and a version. So within FireFly, just about everything is encapsulated in a namespace. And so a namespace is just a way to group data and messages and definitions of things. So within a namespace, the name and the version of a contract interface needs to be unique, because that is going to refer to a specific smart contract or a specific version of a smart contract. So I'll just call it ERC20 with data. You can name it whatever you want. There are some conventions that it needs to conform to, but you don't have to name it the same thing that I am here. That's fine. And I'm just going to say that this is version 1.0. Now I'm going to go over here, and on the server code, I'm going to hit run. So this is what I'm basically doing is I'm telling the sandbox backend server, make a request to FireFly's API to broadcast this contract definition. And what do I mean by broadcast? Well, so a variety of things just happened there. We see that there was a transaction that was submitted. So actually, sorry, first immediately we got a 202 accepted, and then we got an ID back. That's a message ID that we can look up in FireFly to see what happened with that message later, and we can see what the result of that request was. So FireFly uses an asynchronous programming model. So when you make a request, oftentimes you get an ID back, and you can use that ID to look it up later. You can also set up a WebSocket listener to listen for events if you don't want to. And that's actually the encourage model. So rather than polling for status, your application can receive updated status in real time. Okay. So over here on the right side, the sandbox does have a WebSocket set up, and it's listening for events coming from FireFly. And we can see there was a transaction that was submitted. We received a blockchain event. There was a contract interface that was confirmed, and the message that was used to broadcast that was confirmed. So what happened there under the covers? Let's go to answer that question. Let's go take a look at the FireFly Explorer and see what happened in FireFly now real quick. All right, so I'm just going to open a new tab. This is, if you're curious how I got here, if you go back and look at where you started up your FireFly stack, there were some URLs that got printed out here. And so I'm just looking at web UI for member 0. And this is the link right here that I've just opened in my Red browser. So this is the FireFly Explorer. This is a kind of a view into the system, a view into both my node and my node's perspective of the network. So we can see a network map. We can see our red, blue, and green members here and each of their nodes. We can see some information about my node that was all the plugins that I'm currently using. And we can see there's a little bit of activity here now. So there was a batch pin. There was a message confirmed, contract interface confirmed. And so what is a batch pin? You might be wondering. Well, FireFly will take, if there's a bunch of requests coming in all at once, it will batch them together for efficiency. It will hash them, and then it will pin data to the blockchain, hence the name batch pin. And so what's happened here is when we broadcasted this contract interface, it was sent to, there was a message that was sent to all the other members. So we can actually go look at let's go look at the green node here as well and open up its FireFly Explorer. We can see that it has some of the same things. The transaction wasn't submitted from this node, but we see we have the same events over here. Contract interface confirmed, message confirmed, blockchain event received. So what happened is when I broadcasted that, FireFly took the payload of that JSON document. It hashed the payload. It pinned the hash of that to the blockchain, and it put the actual JSON payload on IPFS. And then all of the other members are listening for blockchain events that are happening on the FireFly batch pin contract. They all saw the event. Oh, hey, something was pinned to the blockchain. What is that? Let me go get the data payload that's associated with this. Oh, it's a contract interface. Great. Let me store that in my database now. Now I'm aware of this contract interface that was just declared. So if we go to any of the members now, we should be able to look at the blockchain section here in the dashboard. And we see there was a batch pin event, but we can also go here and we can look at interfaces, and we see that there is this interface that's been defined here. That's cool, not very useful yet. We'll get to where it's going to be really useful in just a second. I just kind of wanted to describe something, kind of what's going on behind the scenes when we're doing all these things. Okay, let's go back to our red members sandbox here. And now what we want to do is we want to actually use this thing. So right now we've just told FireFly about the shape of it, and that's it. And so next I'm going to go to register a contract API. So what this is going to do is it's going to build an HTTP API, and it's going to build a Swagger UI for us to work with all of the functions on here. I'm also conscious of time. I realize that I want to leave time for discussion at the end, and we are rapidly running out of time. So I'm going to try to speed things up a little bit. I hope you can follow along. If you get lost in this part, this will all be recorded. So hopefully you can kind of go back and walk through some of these things with me after the fact. But there's a few more things that I want to show here. Okay, so we're going to register a contract API. I need to give it a name. This name is going to be part of the URL path, so it needs to be URL safe. And so I'm just going to call it ERC20. And we need to give it an address. For this, we're going to hop back over to where we used Hardhat. And remember, I told you to save these addresses. We're going to copy the address for the ERC20 contract, and we're just going to paste that into this box right here. So this is going to tell FireFly, hey, that contract interface that I broadcasted earlier, I want you to generate a REST API for me. And when somebody calls HTTP methods on it, I want you to send blockchain requests to this address here. So we're going to broadcast that. This also gets broadcasted and pinned to the blockchain the same way as our interface did. Now that I've done that, I can go here, I can hit refresh, and then I can see that I've created a contract API. So let's go take a look at that now. We'll hit this little pop-out button. And here is a Swagger UI that has been dynamically generated by FireFly that gives us a listing of all the endpoints that we can now use to interact with our contract. So let's do something with our contract now. This is kind of the whole point of everything that we've been building up to here. So let's mint some tokens first. We don't have any right now, so let's we'll mint. So in this case, we're going to call the invoke mint with data function or endpoint rather. Here it is. I'm going to hit try it out. I need to fill out a couple things. I need to first tell it how many. Let's just do. We'll do 100. I can give it some data. I don't actually need to give it any data at the moment, so I'm going to do. I'm just going to put 0x00 here, and then I need to tell it who to send it to. I'm going to mint it to myself, and then we'll do some transfers to the other members here in a second. To find out, what's the red node's Ethereum address, because that's an important thing to know here. I'm going to go back to the FireFly Explorer, look under Network and Organizations, and I can see there's one labeled Your Org here. Okay, so this is me. I'm going to click here. There is a verifiers section here, and that has my Ethereum address. I'm just going to hit this button to copy it, and I'm going to go back to my Swagger UI and paste that here. Okay, again, if you're looking to figure out where did I get that, I went back to the FireFly Explorer. I went Network, Organizations, and then I clicked on an org here. Okay, so that should be enough to mint 100 tokens. We're gonna run that. We get a 202 back. It's great. Let's go query the smart contract and see, do we actually have a balance now? And so to do that, we're going to scroll down to the query endpoint and we're going to check balance of, and I'm just going to paste my Ethereum address here, run that, and we get 100. So that's cool. Let's check one of the other members and see if they have any balance, just for the sake of the example. We'll copy the green members address. We'll paste it here. We would expect none, and indeed we have none. Okay, so only the red member has a balance right now. Let's do a transfer real quick. So I'm going to go to, let's see, I'm going to just scroll back up here. I'll collapse this just to save some space. Okay, invoke transfer is what we want to do. I'll hit try it out. Let's send we'll send the green member, send them 10. And I'm going to paste the green member's address there. Run. We got a 202. So that's, the request was accepted. We don't know that it necessarily went through, but we can go back down here and then check their balance again. So it was previously 0. I'm just going to execute the same one. And then now we've got 10. Okay, great. So we've done a mint, we've done a transfer. We've done that through FireFly's custom smart contract support, which is really cool. So, we're working with an ERC20 contract here. But maybe your contract has custom functions on it that you want to be able to use through FireFly as well. Or maybe you're working with an entirely different type of contract that's not an ERC or something like that. The FireFly is approachable. It has really easy to use APIs, but it also is powerful and gives you full control of using any smart contract with it. But this was still quite a few steps. And there's still, if I want to build an app that has a whole token economy, there's still a bunch of things that I need to actually build a robust app. For example, I'll just throw one of them out there. What if I want to see the whole transaction history of everything that's happened on this coin? Or what are the wallets that have been interacting with it? Or what are people's current balances? So let's take a look at the FireFly Explorer real quick. There is a token section here, and it has a dashboard. And you'll notice there's nothing in here. We've been working with our ERC20 contract through the custom contract support in FireFly. But at this point, there was a question that was asked earlier. What is the role of the token connector? And I haven't answered that question yet, and I'm about to now. This is where the token connector comes into play. We haven't actually told FireFly to go, index the history of this contract, listen for events on it, or any of that stuff. Any of the kind of all the plumbing and transactional history and things that you need to actually build an enterprise app with the token economy. So that's what we're going to do now. So that's kind of what this middle column here is about in the sandbox, is using FireFly's rich first-class token support and tokens APIs that are built in. So first of all, I'm going to create a token pool. I'm going to call it FFC for FireFly coin. The symbol is FFC. That's what is also in the contract. If you specify a symbol here, it needs to match what's in the contract. And I'm going to get the contract address. So again, to get that, I'm just going to go back to my terminal and copy from where we deployed this from Hardhat. And so if we look in the FireFly Explorer, our tokens dashboard is looking pretty sad right now. There's nothing there. But as soon as I run this, we're going to see a variety of things happen. So we created a token pool, and all of a sudden, we told FireFly about the address of the contract. And this now tells FireFly to start talking to its tokens connector, which is aware of how an ERC20 works. So between the combination of FireFly and the token connector and the blockchain, it's going to build the transaction history and store that in our database. It's going to populate the FireFly Explorer, and it's going to give us a much richer view of what's going on with our token contract. So now let's hop back over to the Explorer. We'll just reload it, and all of a sudden we start to see this dashboard come alive. We've got some token transfers that have happened. We have a history of a mint and a transfer. We have we can see our account balances here of, this is the original 100 that we minted, and then we transferred 10 of it to the other member. And we can see our token pool here. We can click onto any of these things and kind of drill down into them to get more details about them. So we can see this is using the ERC20, ERC721 connector. It's a fungible pool. It has 18 decimal places, and we can see the contract address and all this good stuff. And so all of this just became available to us because we created this token pool and told the tokens connector that FireFly is using about this contract, and it has built kind of this rich dashboard for us to use here now. This also opens up the FireFly first class minting, transferring, and burning APIs as well. So we've already minted some. We can see our balance here is 90, but let's do some transfers from here now. We can do a transfer right in the sandbox. We don't have to go into the Swagger. The cool thing is we don't even have to actually go look up Ethereum addresses because the sandbox is now, it's aware of all of these things. So I believe we transferred some to green before. I'm going to transfer some to blue now. Let's send another 10 over to blue, and we'll hit run. Okay, and let's go take a look at the blue members dashboard now. We haven't looked at that one. So we're going to open up FireFly Explorer on this one. And let's take a look at the tokens section here. And now we can see, yep, our balances are being updated. The first member has 80 and both of the other members have 10 now. We can see both transfers here. And again, if we were transferring with data, we could also look up the actual the blockchain event and see what that data was that was attached to the transfer as well. So there's a lot of information you can kind of dig into here. And then let's, for the sake of the completeness of the demo, let's burn some tokens too. Let's burn 10. I mostly want to show this because I just think the burn icon is the coolest one in the dashboard here. If I refresh, there's our burn icon. It's just straight fire. Okay, and then let's just make sure our accounts have updated. Yep, so we had 80 and then we burned 10. So we've got 70 because we've transferred 10 to each member and we burned 10. So our account balances are continuing to update there. So hopefully you've been able to kind of follow the journey here. If not actually doing it, but you've been able to follow along and it's made sense. If, we've started with our own ERC20 contract that we compiled, we deployed it to the chain. We told FireFly about it. We accessed it directly with our Swagger API. And then we used FireFly's rich token support to start indexing the complete history of the token contract, even before we made FireFly really aware of the fact that this was an ERC20 contract. It was able to go build that history even back before we told it about that. And so there's one other just quick, I'll just real quick walk you through the last tab on the sandbox, and then we'll kind of wrap things up and then leave some time for some discussion and Q&A at the end here. But I also just wanted to briefly touch on the messaging tab because this is kind of like we've talked a little bit about messaging when we talked about broadcasting, but this is the other foundational building block in FireFly of building enterprise Web3 apps is, sometimes I just need to get a piece of data from one organization to another. I want to use blockchain to do that. And sometimes I need the data itself to be public. Sometimes I need it to be private. FireFly supports a variety of different combinations there. So in the sandbox, if I just hit expand, send a broadcast message, and sure, we'll just send, this is a message. We'll wait for the event to go through. It's great. Now to see messages, I can look in the off-chain tab here and look under messages. I can see there was a broadcast message. And here's the data that was associated with that. The data could be, in this case, I just sent a string. It could be a JSON object. It could be a file. It could be a binary attachment that was referenced by ID. And I'll demonstrate that in just a second as well. Just for the sake of the demonstration, let's pop over to one of the other members. We'll look at their, we'll go to off-chain, look at messages. We should be able to see that same exact, yep, this is a message. Here we go. So that went to everyone. We can look at the blue member as well. Look at their messages. Okay, this is a message. Great. Let's do just a slightly different scenario here. Let's send a private message. In this case, as a hypothetical example, I have a file that I need to send from one member to another. And so I'm going to go to the file attachment toggle here. I'm going to choose a file. On my desktop, I have a really cool picture. It's the FireFly logo. It's a PNG. It's it's not too big. It's 20K, but 20K is still a lot to store on chain. So what we're going to do is this file will actually get stored in IPFS, and then we're going to send a basically it will send this is a private message. So it is not stored in IPFS. This uses FireFly's data exchange. I'm sorry for I misspoke there briefly. This will use FireFly's data exchange to directly transfer this file from one member to another. And it will still hash and pin the file, the payload of it, to the blockchain so that I, as the red member, can attest that, yes, I actually had this data, and I can prove that I had this data on this date. So we're going to send it from red we'll send it to blue, and then I'll hit run. That will upload the file. It will send the private message. And so we should be able to go over to the blue members dashboard now, and let's look at the data tab here. And here we can see we received this data. It's about 20K, and I can just click right here and I can download that thing. I can open it up, and there's my image that I just sent. That's great. Just to prove that it was indeed a private transfer, let's go to the green member who should have been completely in the dark about the contents of that message that was sent. And we will jump over to the data tab here, sorry. And we can see that the last thing that it has was, this is a message. It does not have the private data that was sent from the red member to the blue member. Okay, so hopefully you get an idea of the things that you can do in the sandbox, kind of the three, what I would describe as the three pillars of FireFly features: messaging, tokens, and smart contracts. And there's a lot that you can do with them. They give you the very powerful building blocks to build enterprise-grade Web3 applications. And hopefully this gives you enough of a starting point that okay, I can go from using command line tooling and building my own contract. I know how to deploy it to a chain. I know how to use FireFly with that contract. I know how to do tokens transactions. And I know how to send messages now between applications. These are some of the building blocks that you need to build a Web3 app. So hopefully this has given you enough of a starting point that now you got the creative juices flowing, and you're thinking of all the different things that can be built with these functionalities. Just real quick, would like to, but before we jump into open discussion at the end, I never like to let a good opportunity go to waste to invite people to join in the FireFly community. This is an open source community, and it's, in my opinion, a very open source community. We would love for you to join us on Discord if you're not already in there chatting in the channel for the workshop. Please come over and join us. We'd love to continue the dialogue. Myself and a bunch of the other maintainers are in there on a daily basis, chatting with folks, answering questions about FireFly. And it's also a great place to give for us to receive feedback too, of like, hey, I tried this thing and it didn't work. Oh, well, that's not expected. Let's take a look at that together. Also, the source it's all open source. It's on GitHub. Go check out the source. We would love if you have ideas of things that you want to build on FireFly or new plugins or feature enhancements. We would welcome contributions to the project. So come chat with us, come check out the source, and we'd just love for more and more people to get involved in this project, because I think it's really exciting and I think it has a lot of potential. So thank you all for listening. I think at this point we are going to kind of transition now into Peter Broadhurst, one of the other maintainers on the project, wanted to talk a little bit about kind of future roadmap and where is the project going from here, because I'm sure a lot of people are really curious about that. And then we will open it up for just open discussion after that. If people have questions, we can discuss whatever topics that people want to talk about. So I think we have about 24 minutes left. So I will go ahead and turn it over at this point to Peter. But thank you all very much for following along in the workshop today. I really appreciate it.
Thank you so much, Nicko. I'm just going to start sharing my screen here. So before we go into roadmap, I'm just going to recap a little bit. I hope everyone's enjoyed getting your hands on FireFly, no matter how far through you got during the session today. The Discord is there keep going with it, keep chatting with us. It will be great for you to make sure you get to the point that you've got that sandbox there. So the journey that we went through was use the CLI, which is a developer tool just to get it running on your laptop. It gets all the components running. It gets the blockchain running. It gets FireFly core running. It gets all the connectors, the tokens running. It's not a production deployment tool. So production deployment, how does that work? Kubernetes, Helm, DevOps tooling. I would love to have that conversation on Discord, but that tool gets you that environment running on your laptop. You then have the FireFly Explorer UI, which is a lot like a block Explorer will be for just the blockchain layer. This is the tool that lets you see what's going on in FireFly in all the layers, the blockchain, and then all of the off-chain pipes and the tokens and everything as well. And then this absolutely fantastic tool, which you saw Nicko demonstrating, and hats off to the community members that built this over the last few weeks. It just lets you experiment with all the different things that FireFly can do. So I hope you get to the point you've got all those tools there and you can really experiment. I just want to take a little bit of a step back at this point and kind of talk about what FireFly does today. Before we talk about roadmap, let's just talk about what, you install the V1 of FireFly, what have you got? So what do we mean by a SuperNode? It's a way for you to build applications that are decentralized, Web3 applications, on top of a set of APIs. So those APIs are there for you as an application developer. APIs that allow you to connect to custom smart contracts that you've built, and APIs that let you do kind of really quite complicated things like on-chain, off-chain data coordination, broadcasting data to everybody in the network that needs to be put on a system like IPFS, so it's shared with everybody, but it doesn't fit on the blockchain. Sending data securely directly from one member to another member or to 3 different members backed by the blockchain, but data that can't go onto the blockchain because it's too sensitive or it needs to be deleted. So these flows, the sort of data exchange patterns, multi-party business process flows, APIs that just do that as a pattern on top of those core Web3 capabilities. And then digital assets. And anyone who's seen blockchain knows just how important those digital assets are to building use cases. Whether it's uniqueness, these NFTs in an enterprise context, knowing that everybody's referring to the same thing in the world, those NFTs, or whether it's exchange of real value, digital settlement, exchange of value in a tokenized economy. APIs for that, including all of that plumbing that you need to build, like the off-chain indexing, all built on sort of the core of FireFly is an orchestration engine. Kind of think about FireFly as doing for blockchain what something like Kubernetes does for Docker. It sits a layer above and helps you orchestrate all of those things together. So that's what it is at its core, is this orchestration engine. And in the middle of it is an event-driven programming model. I hope you find that really comes through as you're using the sandbox, is everything in blockchain, whether you use FireFly or not, the only way to program in blockchain is through an event-driven model. So FireFly helps you with that. It makes it easier for your applications, lets you use things like WebSockets, to try and make it easier to build. So it's a platform for building on. And if we just look at a more technical view, rather than a feature function view, sort of the last chart was the marketecture, this is the architecture, and look at the components of it. It sits as a layer. In past generations of enterprise software, we've called this middleware. It sits between the application and all of those core backend data systems. So whether that's public blockchain, I know there's questions about public blockchain, we're going to talk for a minute about that. Whether it's your own pluggable private blockchain, You know, whether it's Hyperledger Fabric, which we didn't see today, but super simple to get started with, just as easy as with Ethereum today. People like Jim Zhang, who's one of the TSC members, is a key contributor to the FireFly community. So, you know, you can choose your enterprise version of blockchain. That we'll talk about sidechains as well, but all pluggable. So that these core sort of blockchain native technologies, but then also it sits on top of the sort of off-chain data, again pluggable, things like shared storage, IPFS we talked about, and then your own private data bus, because almost certainly if you're building for enterprise, there's going to be data that's too private to go onto the blockchain itself. So it sits as this layer in between, and it's a microservices architecture. So the reason why we were talking about, well, how much memory do I need? Well, you first need Docker, and you need to have all these containers running on your laptop, because it's designed to be pluggable. And nowadays, pluggable means microservices. It means a Dockerized Kubernetes native deployment model. So that's what it is, the way it's constructed. No detail, no time to talk about the detail of what all of these different components are in this session. And at its core, it has a database, a private database. And this is something that's really important. FireFly is stateful. It has your private data. It's designed to sit at the boundary between your domain and the blockchain where everybody else is participating as well. It's your view of the world. The private data that you may be exchanging with that network of participants and the blockchain data, all indexed in a fast off-chain database. So just wanted to make sure that everyone was on the page of what it is right now today. And let's talk about some of the roadmap items that we're working on immediately coming out of V1. A bunch of these are already started and in flight. There's always room for contribution, new contributors. So if you've got skills you want to bring to the project, Nicko's a great person to reach out to talk about how to get involved. But all of these threads are ones that you can participate in, but there's also other threads that you could work on as well. If you are interested in contributing. But key focus areas, one is no surprise being an enterprise-focused technology, and where enterprise adoption of blockchain's been for the last few years. FireFly evolved, and actually many of the components have evolved over the last 4 years of production deployments on sidechains, on enterprise private blockchains that are secured with a sort of hard boundary. You have to be permissioned in, you have to be able to join the club to have access to it. Technologies like Hyperledger Fabric, Hyperledger Besu, and even Corda. Nowadays, the lines between whether a use case or Web3 use case needs just a sidechain or just public is being blurred. It's really common to need a mix inside of your business, inside of your projects. So we're seeing the lines of separation between what used to be, you know, obviously this is going to be on a sidechain, and what used to be, well, obviously this is going to be public. Those lines are blurring as more and more layer 2 and other sort of proliferation of public blockchains and permission public blockchains are happening. ZK rollups and all these technologies that are meaning that those things are happening lots and lots more. And as enterprises are thinking more about digital assets, business to consumer use cases. So this is a big area that we've got a big focus on at the moment. There's another focus around additional sample applications that show things end to end. The sandbox is so fantastic for seeing what FireFly does, all the different individual operations. But what does an end-to-end Web3 use case look like? SDKs, there's a Node.js SDK. Hats off to Andrew Richardson, who led the development on that one. But there's a goal to have SDKs for other languages, Java, Spring Boot, etc., for all the variety of application development platforms that people work in. And then sort of slightly beyond that, talking to lots of different blockchains from a single FireFly instance. Some of this is available today. You can actually connect token connectors to token economies in multiple blockchains today on FireFly. But that core sort of bus where you're doing the the custom smart contracts, etc., you're tied to one blockchain today. So that's a model that's going to sort of evolve very quickly, we think. And then another area there's a big focus is on, if this is your gateway to the world and multiple blockchains, and there's multiple people that your organization is connecting with in lots of other different blockchains, how do you manage those connections? Who am I connected to, and what are those identities? That sort of outbound gateway security is another area. And then some more features sort of built in, rather than just in the Kubernetes layer where they've been used in a lot of production deployments today. Actual pluggable API security, extensibility in the core API as well. So that's that. I'm going to just take one more minute before we just open for questions. And I'm just going to focus in on that public chain, and I'm going to give you a teaser of where that's going. So connectors inside of FireFly to date. We've had a connector for Ethereum called ETHConnect, which is a very mature technology that's been evolved over the last 4 years. We have a similar solid project there for Hyperledger Fabric, and there's another project for Cord apps on Corda, which is you need to customize a little bit more to your Cord app. Those are really focused on chains that work really predictably. They have enterprise-grade features inside of them for streaming transactions to a predictable blockchain, getting transactions there really quickly. But they expect those transactions to be really final very quickly. So once they're on the chain, you know that they're there. That's not the way most public blockchains work. Most public blockchains work, it takes a lot of time and effort and gas management and resubmission, and maybe you're going to need to increase the value that you've given to people to include your transaction in the block. Public blockchains work in a slightly different way. So we have this evolved architecture, which has come along specifically for public blockchains. I'm not going to go into detail here, but come along to the community sessions, which run on alternate Wednesdays, to learn more about this, because we're going to do a deep dive on this in one of the upcoming FireFly community sessions. But here's the highlights. A new, quite significant component, microservice component inside of FireFly called the Blockchain Transaction Manager. This is responsible for nonce management now being pulled away from those connectors, and it's responsible for things like having a policy engine that can talk to external gas station and make policy-based decisions on things like resubmission, and look after your transactions for minutes until they make it onto the blockchain. And things like the event streaming, which is traditionally for ETHConnect and FabConnect, been all the way down in the connector to the particular blockchain, are moving up into this blockchain transaction manager. So this becomes the heavy lifter. And then the blockchain-specific API connectors, and ETHConnect now has the first one of these there in the repo, are really easy. You've got a new blockchain. I want to just add support for the way that it does transaction submission, the way it does encoding. I want to add that blockchain in. Building one of those connectors is now a very small job with this new architecture, because you don't need to rebuild the heavy lifting. ETHConnect and FabConnect both have all of that stuff inside of there. So this is a really significant evolution of the architecture of the FireFly overall picture. And this means that plugging in to tens, increasingly we're seeing hundreds of different blockchain ecosystems out there. Plugging your ecosystem into FireFly over the coming weeks and months is going to get much easier and easier and easier. So I talked for a few more minutes than I hoped to there. Thanks for indulging me. I hope that was useful background covering what we've done and what's happening next. Back to you, Nicko, if you wanted just to do an open question session.
Thank you, Peter. Appreciate the recap and kind of the look ahead there. It's really exciting stuff. And as Peter said, if this sounds exciting to you and you want to get involved in the discussion about the future of the project, in addition to getting involved in chat and Discord, our every other week community calls are a great place to have kind of the deeper discussion and dialogue with maintainers and other community members. All right, so at this point, we've got a few minutes left. I will open it up. Again, please there's quite a few folks still on here, over 100 people here still, which is super exciting. So let's just try to you raise your hand if you have a question or something you'd like to chat about. And I see Mustafa has their hand up, so you have the floor.
About the connector, we built that using JavaScript, right?
The connector that I showed today is built using TypeScript and Node.js, yes, but
Okay.
there is there's no restriction on what language that has to be built in.
Okay. Then I don't get it. This connector, like it's being called using an API, using an HTTP API that is, or just an RPC or something.
Exactly. Yeah, there's a
okay.
HTTP REST API between FireFly and the blockchain connector. Yep.
And I didn't get that. This connector is specific to it can be specific to a blockchain or can be specific to a contract on the blockchain. It can be both, right? I choose.
It probably should be both because the token connector is the idea is that you will probably, as you customize your smart contract, you probably want to customize the token connector that's working with a specific contract to be knowledgeable about the inner workings of that particular contract.
Okay, so my connector.
Answer.
Go ahead, Peter.
Mustafa, just wanted to be really clear. There's two types of connector that we've talked about today, two completely separate ones. One is a blockchain connector. ETH Connect, Fab Connect, Corda Connect. That's actually, they're written in Go, those connectors today, the example ones. And these connectors will talk to any smart contract. And in the demo and the walkthrough, you actually saw Nicko just teach FireFly about a new smart contract. And that could have been any smart contract in the world. As long as you can define its interface, you can talk to it, you can listen to the events, you can send a transaction. Then there's this separate connector that Nicko was just talking about, which is written, the base ones, the examples, the SDK for writing these is in TypeScript. You don't have to use TypeScript, but that's where the sample is. And these are tied to a particular contract standard. And here we have an API that's specific to tokens, and FireFly understands things like what is a transfer, what is a mint, what is a burn, what is an approval, that you can then, inside of your connector, you can tie it to your particular token economy. Maybe you're doing a security token with an ERC 1400 standards, and you need to sort of customize to that. That's why you might actually need a connector for that as well. I hope that just extra bit of information was okay there. I know you had a bit more to your question, so I'll...
Yes, actually, but I'm still a little confused about the point that are there like specific set of ARCs, for example, that are can have those contract-specific connectors? Like contract-specific connectors, contract can be anything, right?
So FireFly can work with any token contract, but the particular token connector in use should be designed to work with whatever specific token contract is deployed on chain.
So it has, for example, I should write an adapter for if I have an ERC 1155, for example.
Exactly, and that's the repo that Peter's about to go to right now. So there's a different token connector for ERC 1155.
Okay, so most of the contract-specific connectors are focused on coins or on tokens.
Yes,
token standards. Okay.
Yeah, and the reason is because for other contracts that aren't specific to tokens, they might be doing anything in the world, right? I've got a bidding system that, like a like an on-chain version of an auction site, right?
Mhm.
That's going to be very bespoke to the way that you've written that, or a lending library for books, or or a supply chain use case, or like 100 different things. So for those, you don't need a connector because FireFly will generate you an API just like that. You just point FireFly at your smart contract. But FireFly, at that point, it will allow you to invoke every method on your smart contract and to listen to
as long
every
as it has a connector for such network.
as long as the blockchain technology is supported, yes. So if you're on an Ethereum-based blockchain technology, then chances are the support is there or very close. Even if it's public mainnet, if it's EVM-based, you're in a good place. If it's fabric-based, you're in a good place with the connectors that are there today. If some of the other ones are going to need extra connectors, like a Solana connector or these sorts of things, but those are actually going to need a raw blockchain connector. And the existing members of the community are expected to be building some of those. And we expect as the community grows, those to be contributed by some of those blockchain technologies themselves.
And you can think of it this way: FireFly supports any smart contract implementations, but because tokens are such a useful construct in the programming model world, we decided to make it a first-class thing in FireFly programming model. So specific token standards can be supported as a first-class thing.
So yeah, the FireFly UI can understand specifically the workflow of different types of tokens.
Yeah, that's it.
Yeah, thank you guys. Quick question, David, do we have a hard stop at the bottom of the hour, or I'm free for some amount of time after this, so we can.
No, you have the room as long as you want.
Okay, great. So I realize we're running out of time here on the official time on the calendar, but I'm happy if folks have more questions. I'm happy to take a few more here, and if folks want to take questions to Discord, we're also over there, and we can continue dialoguing, hopefully even after today as well. But thanks, good question, and thank you, Peter and Jim, for the detail on that last one. Anybody else have questions that they want to cover while we're all together here today on the Zoom? Well, if not, I guess we can wrap up right on time then. Last call.
If you have time and there's no other questions, I might as well hog the
Sure,
time left.
Go ahead.
So in my head, I have a specific use case for Polkadot. So if I'm to write an adapter for a connector for Polkadot, what I need is something that can talk to Polkadot bar chain, asks for deployed contracts, asks for the API-like thing of those contracts, and convert it to a standard format read by FireFly APIs, right? It's basically it.
I think you've hit the nail on the head there. Would love to continue this conversation. The Polkadot Power Chains ecosystem is high on the list, and there's a lot of active engineering just happening at the moment on this new connector architecture. So if you're literally looking to start coding within the next 5 days, we should sync, because I think you'll find it's there's components moving about a lot. But I think in about a week's time, there's sort of instructions for what's the recipe for a new connector. In about a week, we should have that written down, and that would be a great place to start.
Okay, thank you.
Yeah, Mustafa, CK had a similar question, what about supporting other layer 1 public chains? And I mentioned any of the EVM based or any chain that supports EVM and the JSON RPC would be a really good candidate for sort of the first wave of new connectors. because we already got the awesome ETH Connect that does most of the EVM-based interactions already. So a parachain on Polkadot, like Moonbeam, for example, Avalanche.
Supports already EVM, so yeah, we're already there. Great. But I was looking for others as well, or a custom parachain maybe.
Right.
Yeah, it's definitely possible, but it will just take it's a little bit more work, but definitely custom parachain support is not a, would fit the Firefly model. We thought about it along the way. So I'm sure there will be a way to fit it in. It will just need a little bit more, because you'll have to think about, like you said, the modeling of what does a transaction look like. Because an ABI gives you that for free. But we actually did that for Fabric, didn't we, Jim?
Yeah, so I think the fact that the architecture supported Fabric and Ethereum, which is quite different programming models and different consensus designs, is a proof point that we can support all kinds of different blockchain layers under the cover.
Well, I look forward to continuing this chat on Discord over the coming days and weeks.
All right. Well, once again, thank you everyone for coming out today. This was a great session. I was just really excited to see the turnout and the participation. And I've had a chance to look over some of the chat going on in Discord and excited to continue the conversation with folks over there. Thank you very much for coming out, and I hope you have a great rest of your day. Thank you all. David, do I need to do anything on my side to shut down the stream here?
Nicko, are you done?
Yep, we're wrapped up.
I'll shut it down. Thanks,
All
everyone.
right, thank you. Bye-bye.